Hello Junior Techies, my name is Natasha Barton and today I would like to welcome you to this series of videos in which we will revise matter and classification of matter. In this specific video, I will remind you of what matter is, how we can classify it very briefly, and I will also remind you of physical and chemical properties of matter. Matter is anything that occupies space, has mass, and makes up the objects, materials, or substances that surround us. We too, as human beings, are made up of matter. And we can classify matter by breaking it up into smaller parts. Matter includes mixtures and pure substances. We can divide mixtures into homogeneous mixtures and heterogeneous mixtures. Pure substances, on the other hand, can be divided into elements and compounds. We will study the different mixtures and pure substances in the videos that follow this one. For now, we're going to take a look at physical properties. Physical properties are those properties of matter and materials that can be experienced at the macroscopic scale with our five senses. We start off with mechanical strength. This is the ability of an object or material to withstand an applied stress or load without breaking. So here I'm referring specifically to mechanical strength because you're going to soon find out that in chemistry and physics we have different types of strengths. Below I have a picture of a bridge. Now a bridge would be made up of metal and hard concrete because these are strong materials. On the other hand, if we took this bridge or these materials and replaced them with paper, we know that if a person or car would want to pass across the bridge, it would fall apart very easily because paper is not very strong. The term brittleness refers to objects that are hard but break very easily. For example, the glass that makes up a light bulb. When you hold it in your hand, you'll find that it is pretty hard, but if you allow it to fall onto the ground, it will break apart very easily. Materials are said to be malleable when they can be hammered or pressed into different shapes without breaking. Examples of malleable materials include gold, which can be rolled out into very thin sheets. Different metals can be hammered into different shapes for different uses, like pots, cutlery, or even jewelry. And clay is also a very malleable material which can be easily molded into pots, cups, or maybe even a pot for your pot plant. Materials are said to be ductile when they can be stretched out into wire. For example, copper metal is often stretched out into copper wire and used in electric circuits. There are different types of conductors which we speak of in physical science. Let's start off by speaking about a thermal conductor. A thermal conductor is a material that allows heat to pass through it. Thermal conductors are used to create pots. Pots are made up of metal because metal is a very good thermal conductor. And this is important because when you take your pots and put them on top of a stove or heat source, you would like the heat to travel through the pot into the food that you are trying to cook. Because if that did not happen, of course, your food would not cook or heat up. So pots are made up of thermal conductors. But you may notice that we often use wooden spoons when we are cooking, especially when we are cooking foods like pap, putu, or soft porridge. We use wooden spoons for a very important reason. It is because wood is a non-metal and therefore an insulator. A thermal insulator is a substance that does not allow heat to pass through it. Imagine trying to cook pap with a metallic spoon. Your hand would burn very easily and would make cooking pap or any other food very, very difficult. Another type of conductor that we speak of in physical science is an electrical conductor. These are materials that allow the flow of charge, or in other words, allow electricity to flow through them. A good example of an electrical conductor is copper wire, which, as I've mentioned, is often used to join electric circuits. Copper is a type of metal, and we therefore say that metals are good electrical conductors. Because of how they are bonded, they easily allow electricity to flow through them. Now, you may have noticed a type of plastic or polymer that surrounds most of our copper wires. This is not done just to make the copper wire look pretty, but has a very important purpose. Plastic is a type of insulator, an electrical insulator, and this basically means that it does not allow electricity to flow through it. We cover or coat copper wire in plastic to avoid shocking, and we can therefore say that in general, non-metals are very good electrical insulators. This means that they do not allow charge or electricity to flow through them. The word density refers to the mass per unit volume of a substance, or in other words, how tightly packed matter is. In the picture displayed to your screen, we have a gas, a liquid, and a solid, each with the same volume. When we count the number of particles or smiley faces in the gas, we find that there are 12 of them. In the liquid, we have 29, and in the solid, we have 57. We have different particles in the same volume. And since the solid has the most number of particles in the same volume, we say that the solid is the more dense of the three substances displayed to your screen. It is because it has more particles and therefore more mass per unit volume. On the other hand, the gas, which only contains 12 particles in the same volume, is the less dense of the three substances. The last physical properties that I will speak of in this video include melting point and boiling point. We will start off with melting point. This is the temperature, very important, it's a temperature at which a solid given sufficient heat will become a liquid. As an example, we have pure water or H2O. At a pressure of approximately 1 atmosphere, we have that ice will start to change phase from solid to liquid water at a temperature of 0 degrees Celsius if we keep providing it with heat. So in other words, if we take solid ice and we add heat to it, once we reach a temperature of 0 degrees Celsius, we will start to see it change phase into liquid water. 0 degrees Celsius is therefore the melting point of pure water or pure H2O. Boiling point is the temperature of a liquid at which its vapor pressure equals the external pressure, also known as the atmospheric pressure. To make better sense of this, I'm going to use water as an example. If we take water and put it into a kettle or pot and heat this up, the water eventually reaches a point where its vapor pressure is equal to the external pressure or the pressure of the atmosphere that surrounds it. At this point, the temperature at which this happens is called the boiling point. And you will often find that when we reach the boiling point, bubbles begin to appear within the liquid. The bubbles that appear is basically the water, the liquid water, changing phase from a liquid into a gas. And this happens specifically at the boiling point. Now that we are done looking at different physical properties, I would like to draw your attention to chemical properties. Chemical properties refer to how materials react with other materials in chemical reactions. And for the majority of your time in physical science and chemistry, we will be studying chemical properties and chemical reactions. A few examples of chemical reactions that you experience in everyday life are displayed to your screen. Let's start off with combustion. Combustion takes place when a fuel reacts with oxygen to form a completely new substance, specifically carbon dioxide and water. Rusting takes place when metal reacts with oxygen to form what we call metal oxides. Digestion is very important to us as human beings and takes place when the food we consume reacts with the enzymes in our bodies. The enzymes break the food apart into smaller, more useful substances called monosaccharides, which can be absorbed into our bloodstreams. Lastly, I'd like to bring your attention to photosynthesis, which is very important and is exactly what plants do when they're exposed to light. Photosynthesis takes place when carbon dioxide and water react to form oxygen and glucose, a type of sugar. What you should notice from all of these different chemical reactions is that we have some substances reacting to form completely new materials or substances. This is the essence of chemical reactions. Grade 10s, this brings us to the end of this video. I hope that you enjoyed it and that you will join me in the next video. In the next video, we will be taking a look at mixtures. Specifically, we will look at homogeneous and heterogeneous mixtures.